Now, an additional condition is added to the previous problem, the Tecoviva multi-period cash flow problem. Assuming the CEO has assigned the following risk ratings to each investment on a scale from 1 to 10, 1 being the least risky investment, 10 being the most risky investment. The CEO wants the weighted average risk to not exceed 5 for each month. So let's look at this additional condition and how can we translate it into a constraint. First, let's look at the risk rating. So the risk rating means that, for example, for every dollar that invested in A, that $1 will bring 1 unit of risk to the total portfolio of the investment. Same, for every $1 invested, that $1 will bring 3 units of risk into the total portfolio. And for every $1 invested in C, that $1 will bring 8 units of risk to the total portfolio. Say, for example, if you invest in $1 here to every investment, then the total risk, so the total risk will be 1 plus 3 plus 8 plus 6. So that's the total risk of that total investment. And the weighted average risk means the total money risk divided by the total amount of money invested. So here we invested $4. So this will be the total weighted average risk for the portfolio. Okay, then this per this CEO's request, he wants the weighted average risk to not exceed 5 for each month. So that means the sum product of the money we invested in A, B, C, D. Okay, so I and the risk, and the I goes from A to D. So the total amount of money times their risk divided, and take the sum, divided by the total amount of money will give us the total weighted average risk in each month, and that should not exceed 5. So this is the constraint that we're going to add for each month. Now let's look at in each month how much money are invested. Of course, we can use the actual dollar amount because we don't know how much money will be invested in each investment in each month yet. So we'll have to use the symbol, which are the decision variables that we created to represent this weighted average risk for each month. So now let's look at, so we can either find that from our constraints or from this table here. See, for example, in month 1, for month 1, what is the total amount of money invested? So which investments we put money in? We put in A1, B1, C1, and D1, right? These 4 represent the investments that's the possible investment that we can do in month 1. Since we don't know how much money we invest in each of them, or if we invest in all of them, we'll just use A1, B1, C1, D1. Okay, and from the previous slide, we know that their risk is 1, 3, 8, 6. So A1 times 1, that's the risk, okay, plus B1 times 3 plus C1 times 8 plus D1 times 6. So this is the total dollar risk in the total portfolio in month 1 divided by the total amount of money we have, A1, B1, C1, and D1. So you can see that the unit of the numerator is money risk. And the unit of the denominator is money. So this gives us the weighted average risk because these two are cancelled. Okay, so that's the weighted average risk in month 1 should be less than or equal to 5. Okay, so that's for month 1. And now for month 2. For month 2, let's see which for month 2, let's see which investment do we have. So month 2. In month 2, we A1 matured and we invested in A2. Okay, so A2 is in month 2. A common mistake people may make is that since we're not investing, since we're not making new investment in B or C or D, people kind of forget there are still money in B, C, D, because after we invested in B, C, D in the first month, the money stays there. They are not mature yet. So that means in month 2, we still have money in B1, C1, and D1. See if this makes sense to you. Since we invested in B, C, D in the first month, and they are not mature yet, they are still in our total portfolio. So those money still bring in the risk associated with each of them. Okay, so when we calculate the total risk of the total portfolio, we still need to include these ones. So we'll have A2, every dollar invested in A2 brings 1 unit of risk, plus the money we invested in B in first month brings 3 units of risk from every dollar. And the C1 brings 8 units of risk from every dollar we invested. And then D1. Okay, then the denominator would be A2 plus B1 plus C1 plus D1. Again, this need to be less than or equal to 5. So this is the constraint for the second month. The weighted average risk need to be less than or equal to 5. Now let's look at in month 3, let's see how much money are in the portfolio and how much risk do we have. I'm going to wipe those and let you think about that first. So in month 3, which investment do we have in month 3? So at the beginning of month 3, A2 matures, and then we invest in A3. Okay, so in month 3, we do have in A3. Then B1, we can look at here too. So at the beginning of month 3, we can invest in B. That's here. So these two are new investment. This is A3 and B3. So these are new investment. And the C1, we invested here, still goes to here. And the D1, that's C1. This is D1. This D1 goes all the way to here. Okay, so then in month 3, we have money in A3. And every $1 brings 1 unit of risk. We also invested in B3 because B1 matured. We can reinvest in B3, and every $1 brings 3 units of risk. Plus C1, money are still in there. C1 is not mature yet, so we'll have a C1 times the 8 units of risk brought by every $1 invest in C1, plus D1. Sorry, this is D1. So D1 times the 6. So you can see these two, A3, B3, these are new investments. And the C1, D1, they are the old investments from month 1. But since those money are still in the portfolio, so their risk, the associated risk are still in the total risk portfolio. And denominator would be the total amount of money in the investment. So this is month 3. Now I'll give you some time to complete your constraint for months 4, 5, and 6. Okay, so if you are done, you can take a look at mine. So in month 4, we invest in A4, B3 is still there, and C4 now. So month 4, sorry, beginning of month 4. So here, this is C4. So we have a new investment. D is still there. So A4, C4. Okay, then I'll just show you the rest of them. So in month 5, we have A5. Now B3 matures, so we invest in B5. C4 is still there, D1 is still there. Then in month 6, we have A6, B5 is still there, C4 still there, and D1 still there. So this is these are the constraints to satisfy this additional condition, which is to make the weighted average risk in each month not exceeding 5. Now, when we have this, we can't implement it in Excel just in this format. Can you think about why? Remember we said what kind of algorithm do we use? Or in this chapter, we're talking about what kind of a model. So we're talking about LP model, which is linear programming model, which requires the objective function and constraints all being formulas, linear formulas of the decision variables. And if you look at the left-hand side of those constraints, these are not linear combinations of our decision variables, the ABCDs. We use the sum products of the ABCDs with numerical values divided by the ABCD sums. Okay, so this is not linear. But can we change it to a linear function? Can we change these constraints to linear function so that our model is still a linear programming model that we can solve use the algorithm, which is simplex, that is used to solve only linear programming models? Now let's look at the first constraint. We'll just take this as an example. We're going to linearize it by moving the denominators to the right side, to right-hand side. So we'll have 1a1 plus 3b1 plus 8c1 plus 6d1 less than equal to 5 times a1 plus b1. B1 plus C1 plus D1. In this way, we make this constraint a linear combination of our decision variables. And then we can either implement this in Excel in this way, or we can further simplify it. Further simplify it means moving the right-hand side to the left. Okay, so would be A1 minus 5A1 plus 3B1 minus 5B1 plus 8C1 minus 5C1 plus 6D1 minus 5D1 less than or equal to 0. Then would be further simplify it, would be negative 4A1 minus 2B1 plus 3C1 plus D1 less than or equal to 0. Okay, so this would be the final constraint for month 1. But as I said, this format is also good, and it may be easier to implement in Excel because you will have just one cell represents the sum product of your money in the investment and their risk rating, and another cell representing the right hand side, which is 5 times the sum of the total investment in that month. So with this, we'll just add those additional constraints to our original model. Then we have the complete model for this problem with this additional condition. And you would need to linearize all the different months based on the similar logic and implement in Excel. So here, these are the linearized risk constraints. And you can take a look at them to compare with the ones you have. And we can implement this in Excel.